So I'm Takeda from the Nagaoka University of Technology. So I'm very honored to be here. And thank you very much for inviting me here and also giving me opportunity to join this exciting event. Thank you very much. So I'm doing the collaborative research with Georgian team sitting there under the support of the ISTC. So I'm not the nuclear scientist. I'm a material scientist, material engineering scientist. So we are studying about the materials and the systems for the energy conversion. So energy conversion, not the solar cell, that is very famous technology, but we are doing the thermal energy conversion into the electricity. That is some electrics. So maybe the some electrics is not so familiar. So I'd like to briefly explain about the some electrics and how this kind of international collaborative research is important. So the thermal electrics is the technology to convert the thermal energy heat into the electricity directly. That is very potential. That has the potential for the waste heat recovery. So as you know, the waste heat is important energy source. A huge amount of thermal energy is being wasted. So about the 2/3 of the primary energy is released as a waste heat. So right, this also be. And using this waste heat efficiently could contribute to the effective use of the natural resources and also the contribute to reduce the carbon dioxide emission. So however, the much of this waste heat is below 200 degrees Celsius. So the available technologies to utilize such a low temperature heat are limited. The thermal electrics is one of the technology to utilize such a low temperature waste heat. So I'd like to show you this short demonstration. So this white small plate is a thermal electric device. So we pour the hot coffee into the cup, like this. So using the heat from the hot coffee, so the thermal electric device can generate electricity and drive the motor. So this is the demonstration of the thermal electrics. So of course, after this demonstration, I drank the hot coffee. It's not hot, that's warm, but because the thermal energy, part of the thermal energy of the hot coffee is used to convert it into the electricity and drive the motor. So as you can see, the thermal electrics is a direct electric power generation from heat. The thermal electric conversion is a technology that directly converts heat into electricity by the Seebeck effect of the thermal electric material. So what is Seebeck effect? The Seebeck effect is a physical phenomena. So the left hand side, so left bottom of the image of the Seebeck effect. So we heat the one end of the material. So the electron in the material is moved to the low temperature side. So this creates the inhomogeneous electron distribution. So in this case, the lower temperature sides, the more electron exists. That generates the electricity, that generates a voltage. So when if we connect this electric device, so the material can act as the power generator, like the battery cell. So the thermal conversion has some merit. That is the thermal electric module has no moving part when it generates electricity, as I show you the demonstration. So the result of this thermoelectric material device is long life and high reliability, and small and compact, and no noise and no vibration, and easy add-on to any device or any heat sources. So these features are suitable for the waste heat recovery. So there are some applications already commercialized. As you can see, the bottom side, that is the one of them is the outdoor stove that can generate that can charge our smartphone, at the camping site, or the body heat powered smartwatch, and also the some electric conversion is used as a power generator of the NASA's spacecraft for the deep space missions. So RTG means radio isotope thermal electric generator. Okay. So the thermal electric conversion, the material is very important. So commercially available and the high performance some electric material is bismuth telluride, lead tellurides. So such a material, some of the such material contains a high toxic element and need coating of at high temperature to prevent the oxidation and evaporation of the element. So in the project of the Georgian Technical University team, we improved the performance of the oxide thermoelectric material. So that's stable at high temperatures in air and have low toxicity. So this achievement is an important step towards the application of the thermal conversion for the waste heat recovery. So waste heat recovery, for example, the waste heat in industry, like that, as I show you the left side, and also the utilization, the environmental thermal energy, like the hot heat, like outside or now, or not only the hot heat source, but also that we can utilize the cold heat source for the generate electricity, like this snow. So the picture of the snow campus is our campus in winter season. Our campus has sometimes a 2-meter depth snow in winter season. That is, for me, that is a very, very important heat source for the power generation. So such an environmental heat source can be used for the electricity for the power of the wireless sensor network. Okay, towards the practical application of the thermal conversion, so there are a lot of issues that must be resolved in order to put the thermal conversion technology into the practical use. So several improvements are necessary for the practical application, like the improvement of the heat exchange system or the reduction of the contact resistance, some resistance or electrical resistance and long-term stability of the electrodes and so on. So solving these issues requires various perspectives, experience, and ideas. So international research collaboration is extremely effective to solve the issues. Okay, so thank you very much for your kind attention.